Uh, Hi guys. By the way, I am Willie Asbeapok Jr. and I'm one of our members that are going to explain the program that we have made regarding to on how to determine the liquid limit. So first is we're going to use the Casagrande method, which is there are two situations that are possible na ma-occur, which is first situation is the Kasaganda method, that is moisture content is given, so the moisture content is already given, and the second one is the Casagrande method, moisture content is not given, so the moisture content is not given, problem. So first we're going to to test the first possible problem, which is the moisture content is given. So here we have a problem. So this problem is uh, kinuha namin to sa problem. So this is from our discussion. So we're going to input these values here. And so number of blows is n. So percentage is moisture content, which is this one. So we're going to input the values, which is 18, 23, 30. And second one is we're going to input the moisture content, which is 48.9, 47, and 45. So here, this is the liquid limit chart that the liquid limit chart, or the graph of the table. So here you can see that there is an equation, which is y equals to negative 7.63 ln x plus 70.953. So this is the equation on how we're going to get our liquid limit. So this is the formula. So and y is referring to the liquid limit. So what are we going to do to get the liquid limit is we're going to copy the m. So the m here is the negative 7.633, and the k here is the 70.953. So as what you can see, our liquid limit is 46.383%. So if we compare to the problem, so by the way, the liquid limit here is is on how we're going to get here is by uh, joining these 2 points, which is the number of blows. So where it intersect with this line with the percentage of 46.4. So as you can see, medyo malapit ang yung value nila. So for the second one, so for the second problem here, okay. So the second problem is situation is the secondary method, which is the moisture content is not given. So here we have an example. This example is also from our last discussion. So as you can see, their assumption here for the liquid limit is about 43.7%. So we're going to know the liquid limit by using our the problem we have and the program that we have made. So here, so there's some notes regarding using this program. So in this row, values here are just output. Do not so you do not need to input data. Also in this row, so you don't need to input data. So we're going to input the data given by the example. So there are four test number. So in here, since there are four, so mm, hanggang dito lang yung example natin. Hindi na abot sa 5, 6, and 7. So first number of blows is 39, 23, 20, and 13. So the weight of container, so we have 12.74, 13.24, and also 13.06, and last is 13.27. So for the weight of that surplus container, so we have 22.24, 21.19, 21.27, 26.12. Last one is the weight of dry soil plus container. So in terms of grams, which is the dry soil is 19.44, 18.75, also 18.75. Last one is 22.10. So here, this is our graph for the liquid limit. So this one. So as you can see, we have already the equation, which is y equals to after 3.383 ln x plus 54.427. So same as to the first situation, we're going to let the m as in the equation as negative 3.383 and also the k as 54.427. So as you can see, we have the liquid limit of 43.538%. So we're going to compare with the assumption in the example is the liquid limit is 43.7%. So it's not just uh, near to each other. So it's not kanang layo ilahang gap with each other. So I think our program have achieved the specific uh, requirements for getting the liquid limit. So that's all for the first situation. And the second method is going to be discussed by Mr. Holanda, which is the full cone method. That's all, guys. Thank you.
Good day, guys. So I'm Marvin Olanda, and today I'm going to talk about the Falcon method program using Excel application. So previously, my colleague presented the Casagrande method of determining the liquid limit of soil. So here I'm going to talk about the Falcon method, in which the difference between the Casagrande and the Falcon is that the Casagrande uses the number of blows, wherein the Falcon method uses the penetration in mm. So to test our program, we have here an example. So assuming that we have 5 tests, um, on test 1 we have uh, 13, mm penetration, 15 penetration, 21 penetration, 23 and 25. The corresponding water content is, you have 40%, 38%, 35%, 34%, and 32%. So the our program automatically creates this graph and gives us the given equation wherein the slope in terms of y equals m ln x plus b, where x is equal to 20 millimeters of penetration. So to determine the liquid limit using Falcon, we have to determine the water content at 20 millimeter penetration. So here we have the M of negative 11.15 and the B of 68.51. So automatically we have this liquid limit of 35.107% of liquid limit. So our program is to solve not only for uh, problems that are with water content given, but also we have for instance that water content is not given. So assuming here we have 18 penetration, 23, 25, 27, and 30. So assume that the weight of the container is not uniform. So we have 5.1, 5.0, 5.2, 5.5, and 5.3. So the weight, let's say the weight of soil is 56 grams. Wet soil, that's wet soil, 56 grams, 58 grams, 57 grams, 52 grams, and 50 grams. The dry soil will become, after the soil was oven dried, the weight of the dry soil with the container will be 45 grams, 47 grams, 43 grams, and 42 grams, and 40 grams. So here automatically our problem creates the graph. So as what we did here, we just copy the MB and put it in the box. So the M will be the 4.0793 and the B with 16.396. So automatically we will get a liquid limit of 28.616%. So I think that might be all. In anyways, the our program is just easy to understand. You're just looking at. So here I designed until 7 trials, but I can extend it in as many trials as needed. So good day and thank you for listening.